This is our last lesson in Unit 6, and we're talking about minimizing the surface area of a cylinder. And why would you want to do that? Why would you want to minimize the surface area of a cylinder? It's the same reasons that we've talked about before. Any of these companies, manufacturers, would want to cut their costs of product by having less material. And it's also better for the environment, of course, if you can use less material for packaging. The first 4 points from lesson 8. One is that the maximum volume of a cylinder occurs when its height equals its diameter. So to get the greatest volume out of a cylinder, we need the height to equal the diameter. But if you picture even some of the cans you saw in the previous slide, not a lot of them are like that. So they're not maximizing the volume. The formula for the surface area of a cylinder is this one, and we talked about this one even from the beginning of this unit. The formula for the surface area, though, when you're considering a maximum volume, is this formula. And we talked about the derivation of that formula, where the formula came from in our last lesson. So you only really need this one because from this one you can get to this one right here. Because when the height equals the diameter, we sub that in 2r in for this h here so that we can get our new formula. And the last one is the formula for the volume of a cylinder is V equals pi r squared h. So here's something new. The minimum surface area for a cylinder occurs when its height equals its diameter as well. So right up here, let's say the same thing. When the height equals the diameter, we get the maximum volume. So as luck would have it, well, it's not lucky at all, but that also gives us the minimum surface area. So perfect. We can get the most amount of volume inside a cylinder using the least amount of product for the container in the same situation when the height equals the diameter. So when your height equals your diameter or when your height equals 2 radii. Also, when we manipulate the formula for the volume of a cylinder, this one, and we consider a cylinder with minimum surface area. So minimum surface area means our height equals the diameter, or h equals 2r. So I take this formula, and I sub in for the h, I sub in a 2r right here, we get this new formula. So we again have a new formula. Example 1. Determine the dimensions of the cylinder with minimum surface area if it has a volume of 350 cubic centimeters. So read the question. What information is there that's important? Well, they're mentioning surface area, minimum surface area, but giving us a volume measurement, not a surface area measurement. So what are we supposed to work with, surface area or volume? The question is asking us for the dimensions with a minimum surface area, and it's giving us this volume. So we know that a minimum surface area is also the same as a maximum volume. Those two things are going to happen at the same time. And to minimize surface area, we need the height to equal the diameter. So let's talk first about the one that we actually have a number for, which is the volume. This is the only number we have in this question, so let's start with that. The formula for volume is pi r squared h, but remember, our height is equal to the diameter, which is equal to 2r, because the question said minimum surface area. So if we're talking about a minimum surface area or a maximum volume, this is true. We need the height to equal the diameter. So in for h, I sub in a 2r. When I multiply that out, I now have an r cubed, and the 2 moves to the front. So here is a new formula. This formula gets us, there's a volume, there's a v in front of it, so it's a volume formula, and this is going to be the formula we're going to use for volume when we're maximizing the surface area. 350 goes in there. Now what? Now I'm going to divide both sides by 2. That's 175 equals pi r cubed. Now I'm going to divide both sides by pi. I could divide by 2 and pi at the same time actually, but I just did them in steps here. Dividing by pi, now I've got a bunch of decimals. So I'm going to show 4 decimal places, but in the end I will round to the nearest tenth. What's the next step? How do I get rid of a power of 3? What's the opposite of cubing something? So the opposite of squaring something is the square root. So the opposite of cubing something is a cube root or a third root. So you look on your calculator for that button that has the third root button, and you're going to find the third root of this number right here. This 3 cancels out this 3, and we're left with a single r. And we are not going to round yet, but that should be the number that you got from your calculator. Remember, you're pausing as you need to fill in your page along with the video. So we have r, but what did the question ask for? The question was asking for the dimensions up here. Determine the dimensions. So far we have the radius. That's just 3.8 approximately. Now I want you to look up the formula for the surface area of a cylinder. What other dimensions do we need? It said determine the dimensions. It didn't tell us exactly what that is, so we've got to figure that out. Radius is definitely one of them. So when we're looking for the surface area of a cylinder, determine the dimensions of the cylinder with the minimum surface area. It has this volume. We need the r, and the other dimension we need is the h. So we have to figure out h. Remember that height is equal to 2 times the radius. That's from here, which is from here. Subbing in, we get an h value of 7.6382. So now we have all the parts we need to the question. So now we know the dimensions of the cylinder. The dimensions of the cylinder with a minimum surface area will have a radius of 3.8 centimeters and a height of 7.6 centimeters. That's the first question. The next one we're going to do is similar to this one as well. So we'll go over this again in example 2. Example 2, find the radius and the height of a cylinder with minimum surface area given the volume of 1500 centimeters cubed. So let's just say both of these shapes hold 1500 cubic centimeters of liquid. They both do, but they have very different dimensions. Okay, this one's telling us we're going to find the radius and the height. Those are the 2 dimensions we need. We want the minimum surface area. When you look at these ones, which one looks like it would have a smaller surface area? If you had to package it, which one would require less material? We want to minimize the surface area, but we've got to get 1500 cubic centimeters in there. So we want a minimum surface area. We also have a volume. How do you know if you're going to use the surface area or the volume formula first? Well, we only have one number in this whole question, and the number goes with the volume. So let's start with the volume formula. So at least we have something to sub in. We have a new formula to use now that we got on the last screen. And that comes from the fact that the height has to equal the diameter, or that your height is equal to 2 radii. So that's this formula here. We only use this formula when we're minimizing the surface area. We're getting the maximum volume. That gives us this formula right here. Subbing in the 1500, we have 1500 equals 2 pi r cubed. And I'm going to divide by 2 and by pi at the same time here. Or you can do it on your calculator, and you should get 238.7342 is r cubed. How do we isolate r? Remember what we do to isolate r? We have to do the opposite operation. So to get rid of the power of 3, I've got to take a third root. That will cancel these things out, which means I have to do the same thing to both sides. I have to take a third root over here. That gives me 6.2035. We're not going to round yet. That is part of our answer. The question did say find the radius and the height. So we've got the radius, but I'm going to wait to round it until I get to my concluding sentence. I still have to find the height. Okay, how am I going to get the height if I have the radius? Do you remember? What's the connection between radius and height when we're minimizing surface area? What's the connection between them? Height is equal to 2 radii. So height equal 2 radii, we multiply by the number we got for radius, and we get 12.4070. So now we have our dimensions, and now we're going to round to the nearest tenth. The dimensions of the cylinder with the minimum surface area will have a radius of 6.2 and a height of 12.4. So that's all there is to this lesson. Remember, the topic of today's lesson was minimizing the surface area of a cylinder. So we're trying to minimize the surface area of a cylinder. And when we do that, our height has to be equal to 2 times the radius. That's how we minimize the surface area. And that's that. That's the end of the lesson in 10 minutes flat.